everyone, this video is part 2 of frequency and relative frequency, and we had just finished creating frequency and relative frequency distribution tables for qualitative data, and then we had just started making them for quantitative data. But the ones that we had done for quantitative data, if you will recall, they were a small range of numbers that we had to practice with. But sometimes the range of data is just too large. I'm going to get my pointer up. The data is range of data is too large. What this means is, let's say you had numbers anywhere between 0 and 100. Can you imagine making a table with 0, 1, 2, 3, all the way down to 100? That would make it really hard for the reader to really have a good picture of what's going on. It would just be too much going on there. So if that's the case, what we do is we separate the data into groups, and we call these groups classes. And classes are intervals of equal width. That's an important property of this. Intervals of equal width that cover all values that are observed in the data set. So here is an example, and this is a frequency table that represents test scores. Now, I will tell you that a lot of times when I do this, I go from smallest to largest, but it looks like they went largest to smallest. Oops. So they have the classes 91 to 100, 81 to 90, 71 to 80, 61 to 70, 51 to 60, and then you can see the frequency, the number of observations in each of those classes. Now, you don't see the frequency for the number of observations for any individual test scores, but you do see the number that fall within a range. So there are 4 that fall between 91 and 100, so 4 A's. It looks like 6 B's, 7 C's, 3 D's, and 2 F's. All right, so now I want to go to my little notebook here so I can write and just show you a couple things. Remember, we said it had to be equal width. All right, so let's talk about the width. So 91 to 100, you think 91 to 100, that's 9, but actually that would be 10, a width of 10. And the reason is because if you think of it this way, 91, 92, and the way I got 9 is if you subtract 100 minus 91, you get a width of 9, but that's not how you find class width. So just think of it this way. If we had 91 to 100, we've got 91, 92, 93, 94, 95, 96, 97, 98, 99, 100. So if you were to count these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that's a range of 10, not a range of 9. So you don't get your class width by subtracting the highest minus the lowest. Okay, so what you do instead is you subtract, well, let's just do it this way. Find the difference here. So from 91 to 81, that's 10. If you were to subtract, that's 10. From 81 to 71, that's 10. From 71 to 61, that's 10. And from 61 to 51, that's also 10. So that just goes to show you that each of the classes contain 10 numbers. So they have a class width of 10. And you also notice that numbers between 60 all the way up to 100, I'm sorry, not 60, numbers from 51 all the way up to 100 are covered. There are no gaps. There's nothing left out. There's also no overlap. So notice if this one starts at 61, this class can't stop at 61. This one has to stop just prior, so it stops at 60. This class stops at 70, so the next one starts at 71. All right. So let's look at a couple other things. Okay, so we have what's called the lower class limit. So each classes Each of the classes has a lower class limit, that's the first number in the interval, and they also have an upper class limit, that's the second number in the interval. And the lower class limit is the smallest value that can appear in the class, and the upper class limit is the highest value that can appear in the class. So between 0 and 4, the smallest number that can appear here is 0, the highest that can appear is 4. Now we talked about class width, but this is writing it out so that you can see class width is the difference in consecutive lower limits. So a lower limit minus lower limit. So consecutive means one right after the other. And I don't know why that keeps moving. I just want to point. Oops. So if you do 15 minus 10, you get 5. 10 minus 5, you get 5. 5 minus 0, you get 5. So the class width is 5. So to find class width, lower limit minus lower limit. So here's some rules that are important for classes. First, every observation must fall into one of the classes, so you can't have anything that falls outside. Each observation has to be counted somewhere. And then the classes can't overlap. I already told you that. And each of the classes has to be an equal width. We talked about that. And you can't have any gaps between classes. So even if there's no observations in a class, it must be included in the frequency distribution. So let's say there are no numbers between, let's say there are no D's. Let's say there's no numbers between 61 to 70-ish, something like that. Let's say there's no values there. So you still have to put that class into your table. You just have to write the frequency as 0. Okay, so consider the following wait times on a customer service line, and I'm not going to read all those numbers. That's a lot. And them listed like that makes, your eyes kind of blur. So if we had a separate category for each time, there would be a bunch of categories with a frequency of only 1 or 2. So you wouldn't want to list these out separately. You would definitely want to make classes. So if you're going to do classes, like I said in the earlier slides, the way to go about this is to first decide what you want your class width to be. And if you're creating your own, you can decide what that is. There's not necessarily only one way or only one width that you can use, but there are some guidelines. You want to have more than 3 but less than 10 if possible classes. And so the way to figure this out, to decide your width, is I usually find the range of numbers, which is the highest minus the lowest, and then I divide that by the number of classes that I want. And then you're likely to get a decimal answer, so I usually round it to a whole number and then use that as my width. Okay, so then once you do that, this is the part that people have a hard time with, is they have a hard time because they want to fill all the lower limits and the upper limits at the same time. And what you have to do is you got to figure out the lowest lower class limit, which has to be less than or equal to the smallest number in the data set. And then you fill in all the lower limits first. Get all of those first. And then once you're finished, fill in the upper limits to make sure that there are no gaps or overlaps. So the hard part is people want to do a lower limit and then go ahead and fill in the upper limit before they get the next lower limit, and then they get confused, and then they find out after it's all over with that not all the classes have the same width, and they have everything wrong. So make sure you do all your lower limits first, and then once you do that, you can just create the frequency distribution by counting the number of observations the way you normally would. So let's look at this one. All right, so what we want to do is we want to, these are the following wait times on a customer service line measured in minutes. We want to create a frequency distribution where the class width is 3 and the lowest lower limit is 0. So usually what I'm going to do for this class is I will tell you what the lowest lower limit should be, as well as the width to help you out. That way we all have the same thing. If you were doing this for a project, you'd have a little more leeway and you could figure out your own. So what you would do is the lowest lower limit is 0. So I would fill in 0 first as my lowest lower limit. And then what you do is you fill in your all your lower limits. So you're going to do that by adding the width. So add 3. And 0 plus 3 is 3. Actually, let me do that with the purple. And then you add 3 again, and you get 6. And you add 3 again, and you get 9. And you add 3 again, and you get 12. And you add 3 again, and you get 15. So you fill in all your lower limits first. And then you fill in your upper limits. So to fill in the upper limits, basically what you do is you look at the next lower limit and you just make sure there's no overlap. So if this one starts, this one right here, starts at 3, then the one prior has to stop at 2. If the third class starts at 6, then the second class stops at 5. If the fourth class starts at 9, the third class stops at 8. So why don't you pause the video and go ahead and fill in those numbers. Okay, so hopefully you had a chance to do that. So it's 11. This one would be 14. And the last one, what you have to do is you got to think of what would the next lowest lower limit be. That would be what? 18, which means this one stops at 17. All right, so now there's actually a problem with this, and that's because we have decimals, right? We have decimals in there. So because we have decimals, what if you have a number like 2.5 or 2.7? Where is that going to go, right? So 0 to 2 is the class here, 3 to 5 is here. There's no place for a number like 2.5. So because of that, we're going to add a decimal to each one of these. We're going to make these each 0.9. And I'm only going out to 0.9 because all of the numbers in the data set go out 1 decimal place. If they all went out 2 decimal places, I'd do 0.99 instead. So that way I make sure everything is covered. All right, so I want you to pause the video again, and let me just show you real quick before you pause it. This first number, 0.6. 0.6 falls between 0 and 2.9, so that tally would go right here. All right, so pause the video and see if you can figure out where each of these fall. Then once you do that, write your frequencies and then find your relative frequencies, just like we did previously. All right, so pause it now, and when you come back, we'll go over the answers. All right, so hopefully you had time to go over these. So it looks like there's 5 here, and there's 18. I'm not going to do all the tallies. There's 18 here, 9, 11, 6, and 1 are your frequencies. Those numbers add up to be 50. And then when we do our decimals, our relative frequencies, we're going to divide each of these numbers, each of these frequencies by 50, and you're going to get 0.10, 0.36, 0.18, 0.22, 0.12, and 0.02. And then you want to make sure this adds up to be 1, and it does. All right, so that is all I have for frequency and relative frequency. So if you have questions, send me an email or post on the homework question wall, and I will get back to you. All right.